Okay, shall I start? Shall I start? The second problem today. There's a compressive load along the x-axis 90 MPa, 90, compressive load 60. If you want to take, if you want to, in each problem I'll take a different sign. If you want to just take some other problem, I can take. I've done all types of problem, but this is somewhat different. In both the cases for compression, 60. This is, you see, I can take some other problem. I can do this problem later. You want to see clockwise flow, right? Let us take a problem with clockwise flow. Take this problem. Sigma x minus 100. Generally, in the examination, also give 120 or 140 maximum MPa, so that the scale what you take will be within that 50. Tau, tau is anti-clockwise 25. This is 25. Therefore, this will be like this. This would be like this, and the angle from the vertical. This is the plane where I want to find the state of stress, second state of stress. On this plane, on the given state of stress, I want to find the principal stress and maximum shear stress. On this plane, if I call AE, on this plane I want to find sigma x dash, tau dash, sigma y dash, and tau dash. This is he has given this angle as 60, therefore will be 90, 90, 60. This is theta. Theta is measured in counterclockwise, therefore 30. Okay, and then 2 theta in more circle will be 60 degree. Next, I will write x phase sigma x, which is equal to minus 100, tau, which is equal to counterclockwise 25. This is x phase, this is y phase. Y phase sigma x, which is equal to minus 50 MPa, tau, you can see the difference. Tau in this case is clockwise 25, clockwise 25 MPa, clockwise 25 MPa. Okay, 2 theta is 60 degree, counterclockwise it is 60 degree. Principal stress maximum principal stress is equal to sigma p1, which is equal to minimum principal stress, which is equal to sigma p2, which is equal to, find it out. For the given state of stress, x phase minus 100 and counterclockwise 25. Minus 100 and counterclockwise 25. Let me write it. X phase, this is minus 100. minus 100, counterclockwise 25. That is our tau is counterclockwise. Then it comes to this axis counterclockwise. This is 20, 25 as given. Very difficult for me to write 25. Mm, okay, give me a minute. Okay, x face minus 100, minus 100 is this point. Minus 100, and then I'll draw a line first. So 25. For 25, I'll draw somewhere in between. I will off switch off the snap setting. This is around 25. From this point, I'll draw just a straight line for time being, and then tau is counterclockwise 25. Give me a moment. Draw center line from this minus 100. This is my point x. All this as this as x. Okay, and then y face minus 50, minus 50, and then clockwise 25, minus 50 and clockwise 25. Y face minus 15 clockwise 25. I will take clockwise 25 from here. I will draw a horizontal line. Minus 20 clockwise 25. This is clockwise 25, and then minus 50. Straight. Okay, minus 50 from this point to this point. Okay. I'll call this point as y. This is not straight. We'll call this point y. This point, it has gone somewhere. Don't worry, this point is your y point. This is your y. Okay. Okay. This is the point. This is the point where it intersect. Then from this point, point x to this point, connect the line. Okay. This point is your point x. This point wherever it is cutting, wherever it is cutting, this line has gone somewhere. Maybe Kobridja. Okay, we'll take it. Okay, this slight adjustment. This is center. We'll see. This is center. We need to. Okay. Give me a moment. From, from 50 plus 25 and clock it is how much? Clockwise, clockwise 25 and compression 50 will draw a vertical line, and then from here minus 25, draw this is my point Y, point X, draw a circle, or draw a straight line first. Give these two points. This is my center. This is my center. Assume that it is passing. It is a slight difference. 25 I could not able to plot it. It is passing to that point. Assume that it is passing to that point. Okay. Now, now it is on 26 or 26.5. Hence, it is not passing to that. It has to be 25 when the plot in the graph will get properly. Okay. And zoom it. This is my sigma p1. Or before that, let me. This is x-axis. This is y-axis. In order to let me take that sigma p1. Sigma p1. This is sigma p1. Whichever is negative minimum is sigma p1. There is a negative maximum is sigma p1. In the sense, if there is a minus 45 MPa and a minus 110 MPa, maximum is minus 45 MPa, right? That is sigma p1, and the other is sigma p2. In order to calculate, in order to calculate 2 theta p1, I have to rotate explain towards sigma p1, that is draw a line, draw some for my reference. In your for you, you can do it directly. Okay. I have to rotate my x phase by what angle to get theta p1, sigma p1. This angle comes to be equal to around 133.5 degree. This is your this is your 2 theta p1. 2 theta p1. 2 theta p1 is 133.53 degree, and then sigma p1 is minus 40 MPa, sigma p2 is minus 110 MPa. Okay. Very good. sigma p1, since it is on the negative side, sigma p1 is minus 40 MPa, sigma p2 minus 110 MPa, 2 theta p1 which is equal to 2 theta p1 which is equal to 134 degree, 2 theta p1 which is equal to 134 degree. How it is measured? We just have a look. It is measured from x-axis towards sigma p1 in counterclockwise direction. Therefore, theta p1 is positive. Therefore, theta p1 is equal to 67 degree. 67 degree. Theta p2 which is equal to theta p1 plus 90 degree, which is equal to 67 plus 90, 100, 157 degree. Theta p2, 157. The planes of maximum shear stress tau max, which is equal to plus or minus, wait, tau max. For that, from the center, draw a line. From the center, draw a line. You can draw a straight line using scale, one straight line. Okay. Measure the magnitude. This is tau max 34.8 MPa. In order to achieve tau max, this is my S1 phase. This is tau is counterclockwise. This is my S1 phase. S1 phase. In order to achieve my maximum shear stress, how much I should rotate my x plane, x phase. This is x phase, this is y phase. This is has to be rotated. Let me measure the angle from here to this line. This is 43.3 degree. This is my 2 theta S1, 2 theta S1. In which sense we have rotated to for 2 theta S1? How I have rotated? My x plane to S1, I went in anti-clockwise direction, and magnitude of my this tau max is either this or this, which means as 34.8 MPa. 2 theta S1 is equal to 43 point or 44 degree. You can take it 40. Generally, you should take 43 point because I'm not calculating. I'm rounding off. Okay. Tau max, which is equal to 34.8 MPa. 2 theta S1 measured in the anti-clockwise direction, which is equal to 44 degree, or theta S1 since it measured in the anti-clockwise direction is equal to 22 degree. Theta S2 which is equal to theta S1 plus 90 degree, or theta S2 which is equal to 90, 100, 112 degree. Okay. The plane makes an angle 60 degree. To find the state of stress on the inclined plane where theta is equal to 30 degree and in Mars circle 2 theta is equal to 60 degree. It is measured in the counterclockwise direction. Hence it is positive. 2 theta is equal to 60 degree. Now I have to rotate my x face. Now I have to rotate my x face in 60-degree counterclockwise direction. This is x face. In order to achieve, you can take the compass, let's make this a center, rotate it by 60 degree. Take the compass here, pick the protractor, draw a line from this 60 degree like this. For me, I will do the construction. I'll just draw a line from here, passing to the center, I'll draw a line somewhere like this. Okay. Now 2 theta is equal to 60 degree. From this point, from this point to this point, from this point, this line to this line to this line, this is 85.4 degree. So I have to make it as 60 degree. Sorry, 60 degree. This has to be 60 degree. 60 degree. Let me draw it once again. V point pass to the center. X point has to be rotated by 60 degree. This has to be 60 degree. This is 60 degree, and then this is your, with this point is your normal face, normal. This is n face. This is, this I will indicate this point as your n point, normal point n. This will be your tangential. Okay. In order to measure the magnitude of normal and tangential, take vertical line. This is my normal. From here, drop a vertical line. This is my sigma x dash y dash, and from here I'll drop vertical. This is my sigma y dash tau dash. Measure the magnitude. You can measure this surface. And take this. This is your tau dash or tau 1. I indicate as tau 1. This is okay. Move that. Sitting high. This is my tau 1 or tau dash, and this point is by around from origin, it's around 66 MPa is sigma x dash. Okay, around 85 MPa is sigma y dash. Okay, and tau dash is 33.4 MPa. Okay, this is normal phase, this is tangential phase. Let me write it. Sigma n, which is equal to sigma x tau dash, sigma t is equal to sigma y dash tau dash, which is equal to sigma x dash is equal to this negative side minus 66 minus 66 33.4 that is t minus 96 minus, sorry, minus 85 minus 30 minus 85 84.8 this is your sigma n tau dash sigma n sigma t and then your principal stress and then shear stress principal planes and shear planes. Have you understood this? Have you understood this? Michael, have you understood this? Unmute your mic and tell me. Michaela, have you understood this?
Yes, sir.
Right?
Yes, sir.
Dhruti?
Yes, sir.
Dhruti, have you understood?
Yes, sir.
Lokesh? Lokesh? Rakesh?
Yes, sir.
Sanjay?
Yes, sir.
Sugun? Sugun, did you understood?
Yes, sir.
Okay. I'll stop at this point. I'll send you the image of the graph sheet, the image of the problem which I've solved in graph sheet. You can have a glance at that. You should construct graphically. Well, let me consolidate once again and tell you what you have to do. You should keep these 3 points in your mind. First, you know how to find mark x and y. You mark x and y, okay? And wherever the circle meets, that is this is sigma p1 and sigma p2. Always you should rotate your x. Always you should measure from your x face. From your x face to sigma p1, what is the angle? Since this angle is measured in the counterclockwise direction, this is 2 theta p1 is equal to 133.53 degree. This part is over. I got sigma p1, sigma p2, and theta p1 and theta p2, 90 degree apart. To measure tau max from the center, draw a vertical line. To measure tau max from the center, draw a vertical line. Measure the radius. Measure the radius. This is your tau max. Okay. Now, in order to achieve tau max, my state of stress, that is the x phase, has to be rotated by what angle? To achieve that, always at the bottom, rotate the x phase towards measure the angle between x phase and s1. Wherever the x be, they measure the angle between x and s1. That gives your 2 theta. This gives your 2 theta. Have we done that? That has got deleted, but we have done that. That is 2 theta s1. Okay. Since the measurement is anti-clockwise direction, this is positive. Now, in order to plot n and t axis or n and t faces, that angle is, in case of Mohr circle, will be 2 theta. Whatever the angle phase of that will be in Mohr circle. I have to rotate my x phase. For keeping protector at this center point, I have to rotate by that 2 theta times. In this case, it's 60 degree. So this is n and t axis. N in the sense sigma x dash and tau dash, t in the sense sigma y dash and tau dash. Similar to sigma x, sigma y and tau, we are talking about a new state of stress in the other plane. There is the A plane, which is at an angle of 60 degree. So there is sigma x dash, sigma y dash and tau dash. So I have find this. How to find draw a vertical? Since this sigma axis consists of only normal stress, this indicates sigma x. Similarly, when I draw a vertical, this gives sigma y. This is nothing but maximum normal stress. I can say normal. This is normal stress. Since this is only normal stress is existing here, this on the Mohr circle will get principal stress, but this is not the maximum stress. This is nothing but, since this axis is only for sigma, this gives sigma x and this sigma y, and this length gives your the tau dash. Okay. Any doubts regarding this? Any doubts? Shall I stop at this point? Okay, stop at this point. Thank you.